Okay, so continuing from the previous video clip, I have actually realized that I made a mistake. Actually, mistake was made much earlier. So, for example, for y prime, I think there is no m minus 1 term over here, so I have to delete this term. So it should be here. Yeah, so this term, there should be no m minus 1 term over here. There is no m minus 1 term over here, and also there is no m1 minus 1 term over here. Okay, and now there will be no m minus 1 term over here. Okay, so now I can continue. So it will be m plus 2, m plus 1, am plus 2. So I take am terms on the other side. So it will be plus m into m minus 1 plus 2m, and then minus n into n plus 1, and then am. So I can try to simplify these terms in the bracket. It will be m square minus m plus 2m minus n square minus n. So am, or it will be, now I can write m square minus n square. I can write m minus n into m plus n, and then 2m minus m is actually m, okay, minus n, okay, over, and now so am. So now am plus 2 is equal to, now what I can do is I can take m plus n as common, m plus n as common, and then it will be m minus n, sorry, I can take m minus n as common, m minus n as common, and then it will be m plus n over here, and then there will be 1 over here. Okay, so it will be like this. So, and then m plus 2 and m plus 1 will be here into am. So in this way I will get a recursive relationship, okay, for this. So this recursive relationship is in terms of m and n, okay. So this recursive relationship is in terms of m and n. Okay, so based on this recursive relationship, I can find the values of the coefficients needed for the solution. But given, for example, what will be the values for n is equal to 1. Okay, so when n is equal to 1, so the recursive relationship becomes am plus 2 is equal to m minus 1 into m plus 2, and then over m plus 2 over m plus 1 am. So this simplifies into m minus 1 over m plus 1 am. Okay, so in this case the terms of the equations will be so for example, if I take a table for m is equal to 0, 1, 2, 3, and then I will have the am plus 2 terms as a2, a3, a4, a5 equal to, and then I will have these terms in terms of m minus 1, that will be m is equal to 0. 0 minus 1 is minus 1, and minus 1 over 1, so it will be minus a naught. Okay, and then a3 will be then a3 will be in terms of because it is 1 minus 1, so that will be 0, so 0 times a1. Okay, so that will be 0 actually. a4 will be then sorry, this is a4 will mean that m is equal to 2, so 2 minus 1 is 2 over 3, 2 over 3 a in this case it will be 2. Okay, but a2 was minus a naught, so it will be minus 2 by 3 a naught. And then the next term will be for 3 minus 1 is 2 over 3 plus 1, 2 over 4, so it will be 2 over 4 a3, but a3 was 0, that term will be 0. So this means that the odd terms will be 0, and then n was also odd. N was also odd in this case. So in this case, I can get a series something like this. So y of x for n is equal to 1 will be equal to because our terms are starting from a2, so a naught and a1 will be the arbitrary constant, so it will be a naught plus a1 x and plus a2, that is minus a naught, so it will be minus a naught x square. Okay, and then it will be minus 2/3 of a naught. Okay, minus 2/3 of a naught minus 2/3 of in this case a2 was dependent on a4, and this term was dependent on a2, so a2, that is, it should be a naught, so minus 2/3 of a naught. Okay, so and then that will be x cube. So 0 x square x cube, and then what I will have is next term is 0. Okay, here, no, sorry, it should be x4 because after this term there should be this a3 term, so it should be 0. Yeah, so it should be plus 0 x cube. Okay, 0 x cube, because after that it was 0 x cube. Okay, and then minus 2/3 a naught x power 4, and then plus 0 x 5. So you can see that in this case the only the 0th term, 2nd term, and the 4th power term, 0th power terms are present. For the odd power terms, only the first term is present. So this is the Legendre's polynomial solution. Okay, Legendre's polynomial. Okay, so we can represent it by YL. So YL in this case for first order is equal to x. So this is the Legendre's polynomial. Okay, so and the others are of course a series. So for example, so y2 will be in this case will be a series in terms of a naught into 1 minus x square minus 2/3 of x power 4, and then plus so on. Okay, but the other solution is a polynomial. So one of the solution is a series, infinite series, and the other solution is a polynomial. So in this way we have found the polynomial for the first degree. So similarly we can use this recursive relationship to find the polynomial for the second degree as well. So for this, let's do n is equal to 2. Okay, so for n is equal to 2, so m 0, 1, 2, 3, and maybe even more, a n plus 2 will be then a2, a3, a4, a5, and then equal to. So now n is equal to 2. So for n is equal to 2, now we have to find the recursive relationship for n is equal to 2. So what is recursive relationship for n is equal to 2? So it will be we will put n is equal to 2 over here. So am plus 2. For the recursive relationship will be m minus 2, and then m plus 3, right? And then it will be m plus 2, m plus 1 am. So this recursive relationship will be used for n is equal to 2. So in this case, now the relationships are in terms of m minus 2 and m plus 3. So m is equal to 0 in this case, so it will be minus 1, then it will be 0 here, and then it will be because minus 1, so 0, so m is equal to 0, 0 minus 2, it should be minus 2, then it should be minus 1, and then it is 0, and then it is 1. Okay, this first coefficient. The second coefficient will be 3, 4, 5, 6, right? Because 3 plus 3 is 6, and then divided by 2, 3, 4, and then 5, and then it will be 1, 2, 3, and then it will be 4. So this will be a0, this will be a1, and this will be a2, this will be a3. Okay, when this has become a little bit messy over here, but we can simplify it. Okay, so it will be minus a0 by 3, a0 by 3, and then this will be this was minus, okay, minus 2 by 3, this was minus over here, and this was 4, so minus 4, and then 2, it is divided by 2, so minus 2 by 3, a1, and then this will be 0, and then this will be this was 2 by this was 1 by 2, well, a3 by 2. Okay, and then for example, this is in terms of a0, this is in terms of a1, this was 0, and then this is in terms of a3 was a1, so it is 2 divided by 3, so it will be minus a1 by 3 in this case. Okay, so we will continue we will continue this in the next video.